the big 8 inches floppy drive. If we power it up, you can see that there's nothing on the screen. Look at this. I'm gonna turn on the other camera.
Okay, so I tried powering it up. It didn't work. Now I found that, oh, I hear the flyback. Yeah, see, high level, right? So this is like what is expected from the reset. Oh, finally I managed to assemble it and it's working. Yes, it worked. Oh no. Yeah, what can I say? This keyboard, I'm not sure it's repairable.
Hello, welcome back to NMI. This is the third video of our TRS-80 Model 2 repair series. And in this video, we're gonna take a look at how I repaired the keyboard. And we'll be able to finally check some of the software that can run on this machine. Okay, before we start, I want to answer some questions that I got as a comment on my previous video. So thanks KL. I'm not sure what is their name, but it's KL. So thank you for the questions. And the first one is how I connected the 8-inch floppy drive to my PC compatible machine. In my case, it's a 386, and I'm gonna show you now.
I disconnected the floppy drives from the controller, right? So the connector is there. Then I took my interface adapter with a cable, right? And it has the twist here, right? Connected. Make sure that you have pin 1 aligned there, right? And I disconnected the floppy from the controller, just the data cable, and we connect the interface here, right? Pin 1. Oh, not quite. Yeah, like this, right? I left the power connection, so the floppy drive is gonna run from the machine, like the TRS-80 power supply, and from the AC supplied via like the line connected there. But the logic signals for the control, they come from my 386. I hope that helps with this part of the questions, how this is connected. This is it.
The other question is, how did I find software to write on the disk? And the answer I linked on the video description. I use these two websites: Image Disk Software here from Dunfield, System Disk Images. So this is Dave's old computers. And here you can find a lot of different images for different machines, right? The Osborne images that I got on a video that I already showed here, I got them from this website. There are Nabu images, Lobo. Oh, that's pretty cool. And the K-Pro that we already saw here. And in this case, if you, where is that? Here. TRS-2, Model 2, TRS-DOS, and CPM, right? Another place that it's also linked in the video description is this GitHub repository. And here you have software, and you have a lot of different options. You have CPM software, for instance, WordStar, this CPM version that we're going to use here on this video. What else? Diagnostics that we're also going to run here. Games. There's a lot of Tandy software See here, VisiCalc, Scriptsit, which is a text editor. So there's a lot of software there, and these are usually IMD. Let's take a look at one if we can. Yeah, see, this is an IMD disk image, and on the same website here that I mentioned before, Dave's Old Computers, you can find the tools, the IMD tool that can write these images. The other question, where did I get the floppies? Well, I got them from friends. The first floppies that I used on this series of videos, I got from one friend that also gave me a bunch of stuff that I showed here already on the cool haul not long ago, including that VT101 that I bought from him. But I got a lot of stuff for free, and last year he gave me I think 15 or 28 inches floppy disks, right? And recently I also got this, right? This is a box of sugared disks, and they are all brand new, right? So you can find these things. You can also find them on eBay, right? But if you have good friends, good contacts, you might be able to get some for free. Oh, and the other question, how did I find the settings for configuring IMD? Well, that I got from different places. Let me show you. So regarding the format of the floppy, there are two basic places that I looked up. The first was Wikipedia, because the first place I went was really Wikipedia, and here you have some information, 77 tracks, 26 sectors per track, and so on, right? But I think the best place is the TRS-80 Model 2 Operation Manual, right? And if we go here, page on the specifications here, page 27, here we are going to have the same information, right? Tracks per diskette, 77, 26 sectors per track, 256 bytes per sector, except track 0, and the transfer rate 500,000 bits or 500K per second, right? So this is where I got the information and where you can get the information. I hope that helps. The other question, how did I not kill myself working several times on the flyback? Well, that is not the first time I'm doing that, but I am usually very careful and I take care of discharging the flyback. I probably didn't show that in the video, but I have a 10 mega ohm resistor that I use for discharging, and I have some alligator clips that I connect to the flyback plug and to ground to discharge the flyback. In this case, the machine already have that facility. There is another wire that will discharge the flyback over time. So all you have to do is to wait a little bit, and that's it. But that is very important because the flyback carries very high voltages. But I do not touch any of that, especially the plug, the end plug, when the machine is on, right? I'm not that crazy, right? But when the machine is off, the self-discharging circuitry and being careful and using discharge resistor helps, right? And the last question, how did I remove the power plug of the power supply without destroying the plastic? Well, honestly, there was nothing special there. I believe I was lucky because the plastic there is still good, but I didn't do anything special. I just removed, there are some clips. You just press the clips and remove the connector, and that's it. Nothing broken there. So thanks, KL, for your questions. And if for anyone that is watching this video, if you have questions or comments, please feel free to always comment my videos. And again, share and like and subscribe to NMI. Now let's proceed with what we are supposed to do on this video. Thanks.
Here is what I'm doing. I saw a video on YouTube where the person was manufacturing capacitive pads in-house, I mean at home, right? and he showed a pretty simple process, and I decided to try that myself. And as I'm going to show here, it works perfectly, right? I just adapted, so to say, his kind of bill of materials, right? So I bought this hollow punch set from Amazon. So that is one thing, but that is a one-time buy, right? It's not gonna be something that you're gonna need to replace all the time. I am using the 10 millimeter one, right? As you can see, it has some residue already because I just punched like 100 of these. So this is my kind of product, right? They have actually what, 3 layers, right? There's the top layer, mylar, and I am using 2 layers of two-sided adhesive, right? Foam. Let me show you. At first I bought these ones. They are, I think, 2 millimeter thick, right? And they are double-sided. So they are pre-cut in these squares. What is that? Maybe 40 by 40 millimeters, something like that. I got this from Amazon. Everything here, like the punch set, is also from Amazon. These ones, right? In my mind, I thought that I can sandwich them to reach the whatever is the height that I need, right? And yeah, that worked, but in the end, there is a middle point that I needed to reach. In stacking 3 of these, it gets too high, right? Because it's at least 6 millimeters. I already ordered another foam tape that is 5 millimeter thick, but I also found these at the dollar store. They're pretty cheap, right? They are thick. I don't know, does it say here? No, but they are probably 3 or maybe 4 millimeter thick, double side adhesive too. So that works perfectly. So what I'm doing, I'm sandwiching 1 layer of these guys with 1 layer of this guy, and on top of it, I use this, right? This is a mylar blanket, you know those emergency blankets that you usually see firefighters they give to the victims of whatever, like a fire or something, right? I got that one, like that. Well, it's a big one, but that's just a piece, also from Amazon, along with these ones. But I later found that the dollar store has them too for $1.50. This is Canadian, right? So pretty cheap. And this is 84 by 53 inch blanket, right? So it's pretty big. You're gonna be able to make a lot of capacitive pads, just like these, right? It has some superficial marks or markings, marks here, right? But I assure you that doesn't prevent it from working, and that is what I'm going to show you in this video. I already made, let me show you, a bunch of them, right? Because I have to fix my Model 2 keyboard, as you know, and that is the point of this video. Oh, one fell. But I also got a compact portable, and that machine also uses the same kind of capacitive keyboard, and the keyboard is also dead. So I am gonna have to fix that keyboard too. Not on this video, that's gonna happen some other time. But so in this video, I'm gonna show you, I'm gonna make just 4 of these, right? So I'm not gonna pay attention to the efficiency in terms of material use. That is up to you. For these 4, I don't care. But I'm gonna show you how I can make, or you can make, whatever is the quantity that you need in a pretty simple and easy process. I am preserving the bottom of the capacitive pads that I am removing from my TRS-80 because they are made of kind of a rigid plastic, right? So I am just cleaning them up a little bit because there is still glue here, but I don't care, right? So I am sticking my capacitive pads to the clean, the side that does not have glue, right? The clean side of these plastic discs, and applying them to the keyboard. And let me show you. So this is the work in progress, right? These are all bad, old, and these are new ones, right? These are the ones that I am making. There's a lot of differences here because I was trying out different heights and materials, right? For instance, this is higher than the others, and these 2, I think, are lower, but no, these 2, it doesn't matter, right? There is a lot of prototypes here, right? And here I think these are all new. Yeah, this is also new. And from this, all these other ones, they're all bad, and I'm gonna replace. I'm not gonna replace all of them in this video. I'm gonna do that off camera. So what I'm gonna do now, I'm gonna show you how I can, or you can make a couple of these, right? And then we're gonna jump to the keyboard ready, and we're gonna try it out on the actual machine. I'm gonna start small, just 1 square of this one and 1 square of this one, right? This honestly is lower quality, so we want the mylar to be attached on this one that is better, I mean higher quality, right? So what I'm gonna do, okay, I'm gonna stick them like this, and there's gonna be waste here, but it doesn't matter right now, right? Now I'm gonna cut the excess. Now we take a piece of that mylar blanket. This is, yeah, this part is still good, so we can use this area. But one thing that you need to pay attention, let me show you. We have the multimeter here, and the 2 sides are not the same. So one side is not conductive. The other side is conductive, right? So we need the non-conductive side to be facing up here, meaning that this is going to be the side that is going to touch the keyboard, the PCB, right? So now we need to carefully apply this again, just to make sure. Yeah, this is the non-conductive side. And here we have, now all we have to do is to get our pads from here. I'm gonna use, you can see that I did a lot here. Well, I made like 100 already, right? So I'm gonna use this other side that is virgin steel. Now we need a hammer, right? And our hollow punch. hole here, and you need to make sure, yeah, let's remove the excess because it's gonna be easier to locate where we need to punch. So here we have our big, well, it's not big, well, bigger pad, right? I hope I probably the camera is gonna shake, but it doesn't matter. Now we're gonna get our pads from this guy here, the first one. So we're gonna get 4. I'm gonna use tweezers carefully just on the sides of the pad, not on the center, to extract our pad. Let me try something. Honestly, I did not try yet. And what happens if we go the other way around? Right? I believe it's gonna be worse, but let's try one. No, it's not bad at all. No, it's better, in fact, right? Yeah, so 2 ways of doing it. Yeah, let's do this other way then. Yeah, but the surface of the pad, it's not as nice. Again, I tried the pads like this, the ones that they don't look so nice, and honestly they work very well, so I don't see a problem on doing this, but you're free to use whatever process works best for you, right? Now I'm gonna proceed with fixing or replacing all the pads on my keyboard, and then we're gonna try it out. Look, this is the state of the original. I don't know if they are really original, but the old pads. The phone is just disintegrating and turning into dust. And yeah, some of them they still are metallized like this, but a lot of them are not. Okay, I removed all the old pads, and yeah, I didn't mention before, I also glued together, but there is a piece there falling apart again. I glued together, and I moved or swapped the broken parts of the keys for good ones here, right? So I shuffled around, and now all the keys that make or that receive a screw from the keyboard PCB, they are all good now, and I try to reinforce some here and here, you know, just to make sure that everything is fine or better, right? Because I don't want to replace like having to replace the plastic piece here is going to be expensive, and I don't want to do that. Now I cleaned everything up, and we're ready to install. I have all the discs from the old pads, and I'm gonna reapply or apply a new pad on them, and we're gonna apply them on each key, right? There, one thing that you need to pay attention, there are 4 I don't know the word in English for that. There are 4 small arms, right, or hooks let me see if I can zoom in. There are 4 hooks on each side of a key, right? And the disk needs to make contact with all of them and sit under the hook, right? So that it is secured in place, right? So this is something that you need to make sure that when you I'm trying to put one side so that both 2 hooks are under, or are the disk is under 2 hooks, and then yeah, there's a sound of a click that tells me that the disk is in place now. It's secured firmly there, and we're going to proceed with all keys. Finally, last one. This is a lot of work. Okay, now reconnect the PCB and hope for the best, right? I already cleaned the surface. Now I'm gonna reinstall it on its case, and it's gonna be test time. Okay, here we go. Okay, let's see. Yes. And it's working. Oh. Awesome. It is working. Oh. Look at this. Oh, this dot is not working. Yeah, but it's working. Amazing. I'm super happy. Now we need to image more disks and look at what this machine can do. Okay, so because we are seeing that message during the boot of the TRS-DOS that states that only 32K of memory is present, I decided to, take a look again at the memory cards, because there is something wrong with them. I don't know if there are some defective chips that are causing it to not use a page or something like that, or maybe we still have some configuration issue. One thing that I did was I got this small memory tester here, right? And it can test the 4116 memories here. So I tested a lot of them. Apparently they're all good. And then I started to dig, and I found this technical bulletin, right? And on this technical bulletin, we can see that, look at this. They state that the configuration for the 64K memory board, the jumper should be 2627. And that was the original position that it was before, right? And I moved it to 2719 because this is what is stated in the service manual. But apparently, I don't know if the service manual is wrong or it's a typo. I don't know what is wrong there. But this technical bulletin shows that this jumper here is wrong. So let's change it according to this bulletin. So it goes here, right? And I also decided to take a look at the other 64K card. And here, as we already know, we saw in the last video, this jumper, this one, I don't know if this is right or wrong, because honestly, this technical manual doesn't mention anything about the other jumper positions, right? And here, this is the service manual, and this is what I mentioned, right? And we saw in the previous video. So this is what I used as a reference for the jumper configuration, but apparently this is wrong. And the thing is, looking, where is the, here, looking at the schematics. So this is where the jumpers are configured, those jumpers, right? These jumpers here, right? And we can see that they are configured by the lowest 4 bits of the I/O port FF on the Z80. So when we have a write operation, this latch will store the state of the lowest significant bits, the 4 least significant bits, right? Here, right? And then this is an LS138, so this is a 328 decoder. And now, according to the technical bulletin, this jumper should be connected to this BS output, right? And before, this one was connected there. So according to the service manual, this is the right connection. This guy, J19, connected to J27. But according to the technical bulletin, it's J26. I'm sticking now with this technical bulletin. But for the other cards, that means that maybe we should start from the bottom up. So the next one needs to be 25, right? 17. Sorry, 25, and then what is the 28, right? So that means that instead of having, what is this? 2820. So here, 20 connected to 28. We need to connect 25 to 28. So I am going to change this jumper as well. And now I believe that this should be the correct configuration. Again, I have tested a bunch of memories here. They all look good. So I don't know what was wrong before, because if you recall, the first time I tried this to boot up, we were getting that error, boot error HM, and I found that changing the jumpers fixed the problem. But I'm not sure if that was really the right solution, right? Or maybe it was just one of these memories that was not working properly. Maybe some contact issue on one of these sockets. I don't really know. And maybe just because I removed them from the sockets and reinstalled after testing, maybe that is going to solve the problem. I'm not too sure. So I'm going to put this back and we're going to take another look at the machine. Let's start with the TRS-DOS 2.0A. You can see now that 64K of memory are recognized. And this is it. Now, '31st. Oh yeah, month, day. Okay, month. August 31st, 2025. You can see that the keys are working fine now. And what time is it? 11:37. 11:37. And this is it. I'm not too familiar with this disk operating system, but I know that you need to use capital. Yeah, I'm not sure what is supposed to be on this disk. It seems empty, so maybe this is just the boot. Really, we can see that there's no applications apparently. Let me try something else now. Let me try CPM. There are multiple CPM versions. I read for this machine. This is the Pickles and Trout, and I think this is probably one of the best ones. So you can generate a system disk, generate a data disk. Let's exit. Oh, okay, yeah. The key E does not seem to be working very well. Still, this was the very first time I tried to make the foil and the foam and foil. Sorry, the foil and foam pads, right? So I'm happy with the final result. I'm sure that I'm gonna improve with time and gonna be able to make it a much better version of it. But for now, this is working, and that's what matters, right? I'm not looking for perfect here. I just wanted functional, and it is functional. So if we look at the directory here, yeah, there's a bunch of there are some basic files. Some of these utilities I recognize from other versions of CPM, but some I do not recognize. For instance, density. But yeah, this is probably just this flavor of CPM. So we can see that CPM is working here, which is pretty cool. So this was a major factor on the, well, I can't say that this machine was really successful, but this machine was designed for the business market, right? So that's why it used 8 inches floppy disks, and it could run CPM. As far as I know, this is the only TRS-80 that is fully compatible off the shelf with CPM, right? So that is because Tandy was really focusing on the business market for this machine. Now let's try something else. Since we're talking business, I have a spreadsheet here. Let's see if we can make it work. I'm not sure that, I don't think that is a CPM application. Yeah, it's booting. So this is probably a TRS-DOS application, and it has the boot. Yeah, see? Oh no, I have one. Okay, so 8, 1, 5, now it's 11, 40. Oops. But I'm happy with the keyboard. It's working. Yeah, I can see, I don't know if you're going to be able to see on the video, but the CRT sometimes has some artifacts, or the width changes a little bit, so maybe I'm going to have to do a recap on that analog board. But what is the application here? Is it FST call? No. Error 31. I'm gonna have to investigate what is the meaning of error 31. Okay, let's try something else. Maybe I'm gonna have to make a video just on these applications later. Oh, I have Diagnostics disk here. Oh, this is an older TRS-DOS. I just noticed. This is 1.2. Okay, let's see what we have here. Oh, this disk has a bunch of stuff. There's a menu there. So let's try, oops, yeah, E again. Oh, okay. So this is just a menu. Oh, we can input here. Okay, so let's try the mem test forward, oh, slash is forward slash CMD. Okay, 64K memory test in progress. Yeah, I think this is gonna take a long time, so we're not gonna wait here. So apparently these are all basic games, meaning they're written in BASIC. So I'm not expecting them to be fancy in any way, and they're probably all text. Let's try Star Trek. Okay, Enterprise is in quadrant 6, sector 6-4. What should we do? Report. Okay, report. Condition green. Okay, so how, what, is there any help? Report. Self-destruct. Galaxy map. Oh, but it needs to be capital G. Map of known galaxy. So I think we're 6, right? 6. Yeah, we're here. Okay, let me see the help again. Let's try this sensor. Short range sensor. Oh, okay. Oh, there is what, an enemy or something there? And I don't know what is that. And the long range sensor. Oh, it always disabled the caps lock. Okay, yeah, this is gonna take time and I don't know what I'm doing, so if we do a break, yeah. Yeah, so here we have the game, the listing of the game, right? And can we try a new? Yeah, and now list. Oh, no. 10. Print. MMI. Oh, MMI on TRS-80 model 2. Go to space is also not always working. Okay, let's try running this super complex program. Yeah. Okay, yeah. Let's see if we can find, well, yeah, those games then are going to be all text based. Let me see something else. I have 2 more games discs here. Why it wants to print? Yeah, more games in basic. Again, Star Trek. Try this worms. Oh, cool. This. Yeah, I asked for directions and I didn't get any. Why? Huh. No directions. Let me see. The keys are here, the cursor are arrow keys. Oh, it's too fast. But here are the instructions, but it's way too fast. Or I am way too slow. Oh, but it's not responding to the keyboard. Yeah. Okay. Next. Another disc with games. Yeah, there's a bunch of stuff there, but this one has no menu. Let's try. Can we run this Lunar? No. Maybe we need to do we have basic here? Yeah. Okay. How do we exit? System. Yeah. Okay, so basic. Lunar. Yeah, but it's a cool machine, right? Not sure if there is any, aside from the business application, if there's any game. Probably not, because who would write cool games for a machine like this, right? Its main focus was business, but I might be wrong. Game number 1, speed 2, gravity 1. Oh, this one has some graphics apparently. Or what is this? Oh no. Yeah. Well, I think that's it for this game. Well, that's it for this video. I think at least we could see or have some idea of what this machine could do. Well, not much because we didn't run any business applications. I'm gonna probably make some short videos showing business applications running on this machine. But anyway, I'm happy because we fixed the keyboard. Well, I'm happy because I fixed the whole machine, right? It was not working at all. The keyboard was a mess, all bad, right? And now I have this fully working machine and I couldn't be happier, right? Even though it's bulky, I love these 8-inch floppy discs and this floppy drive. It is big, but it's super cool, right? So thanks for watching. Thanks for sticking with me here. And if you like this video, please give me a thumbs up. And don't forget to subscribe to the channel, to NMI. And see you next time. Bye.